Hello and welcome to our latest installment of the How-To series, How to Alert Beacon Peripherals. Or if you're watching the recorded version of this online, welcome to an installment of our How-To series that may or may not be the latest. This training is going to cover the complete process of Alert Beacon peripheral installation and configuration. We're starting with as simple as taking out of the box and ending with testing their functionality on the Alertus server. We'll be covering all categories of Alert Beacon peripherals today. We'll start with introducing the most common Alert Beacon peripherals and explaining their intended functionality. Next, we'll show how to wire the peripherals to accomplish that functionality. Then we'll walk through the changes required on the Alertus web console to recognize the peripherals. And finally, we'll show the steps for testing those newly configured peripherals. So let's take a look at some peripherals. This is their activation button. It is pretty straightforward. You press the button, it activates the alert beacon, and you perform whatever alert message or alert profile to all alert devices you would like, corresponding with that particular button. Different buttons can correspond with different emergency alerts. You can configure these however you would like, and we'll show you how in a little bit later in the presentation. Next, we have fire panels. These are able to convey the emergency state through a wire that goes from the panel to the alert beacon. Much like the activation button, it sends a signal to let us know that there is a problem, which will then activate the Alertus server. We also have some other inbound integration peripherals. The one shown here is a bullet sound detector for gunshots, but you can use them for all sorts of other sensors. For instance, if a vaccine freezer goes above a certain temperature, that sensor could also be used to trigger the alert beacon. Or if you have an emergency access or access control system set up in your building, those can also be used to send a signal wire to the alert beacon and designate that an alert condition has occurred. We also have some output devices like sounders that play a loud sound and flash. Or if you don't want the loud sound, you can just have strobes that flash or display a light spinning in a circle. Both are just a way to play out the information from the alert beacon, make them more visible, more noticeable. And last but not least, we have the LED Marquee, which is used to display the message on the alert beacon itself. For instance, an intruder lockdown would be displayed on both the alert beacon and the LED Marquee. The functionality of these devices can be grouped into one of three categories. We have input devices that are sending information to the alert beacon. They are used as an activation method for the system. Output devices are the opposite. Information flows from the alert beacon to the device instead. It is easiest to remember these in terms relative to the alert beacon. If the information is being passed into the alert beacon, it's an input device. If information is being passed out from the alert beacon, it's an output device. The next distinction is between dry contact and the RS-232. We'll be explaining this distinction further in the following slides, but this has to do with how the device is wired physically to the alert beacon. Every device except the LED Marquee can communicate through a simple on-off state, so they use dry contact closures. The LED Marquee will require text data from the alert, so to use a more sophisticated connection. All input devices work under the same principle. They're essentially specialized switches like a light switch that can open or close a circuit. When the circuit is closed, it signifies to the alert beacon that an event has occurred, and the alert beacon will send information to the Alertus server. On the right, we have a basic setup. There are two wires running from the alert beacon to a device that form a circuit or a path for electricity to flow. The peripheral has the ability to close the circuit and open it. When opened, it stops the flow of electricity. When closed, it allows the electricity to pass. Their input peripherals are of a type called normally open. As the name implies, they are open normally when they're not active, and that is how they sit on the wall. When they are activated, they close to activate the system. So let's take a look at what this would look like. We have an alert beacon. We have a flow of electricity that is being stopped at the moment. If we want to activate it, we'd flip up the lid and we'd push the button. This would complete the circuit and allow electricity to flow to the alert beacon. Next time the alert beacon checks in with the alert server, it will report that the input relay for the circuit is closed. The server will then respond with the appropriate activation. For this example, we used an activation button, but the exact same process happens for a fire panel or other sensor device. The only difference is with a button, the person physically closes the switch, whereas with a sensor, the sensor triggers the switch to close. Also note that in this example, the alert beacon that is attached to the device is activated, but any set of devices could be triggered to be activated by the switch, not just the one it's connected to. You could even have the one connected to not be activated while other devices are. It's entirely up to your configuration. So as we established, we're going to be using two wires to connect a peripheral to the alert beacon. These wires are going to connect to the back of the alert beacon. There's a green collection of terminals just above the space for backup batteries, and this is where the wires go for peripheral devices. This is an input peripheral, so we're going to be focusing on the selection labeled aux in, which is short for auxiliary input. We can see here that there are two separate channels for input, aux1 and aux2. This is because the alert beacon can support two separate input peripherals. For those curious, the strange down arrow means ground, and in this case just signifies a return path. The complete circuit then would consist of both a number and a return path. These are our two input channels. Now all that's needed is to connect the wires. It doesn't matter what order you connect these wires. All you do is turn the tiny screw for the terminal, the top, so it'll be around here, and it will open up these little clamps. Once you put the wire in, you tighten it back up and it closes the clamp. If you've never done this before, I promise you it won't take more than your second try to get it right. Once you have both the wires connected on the alert beacon, just connect the other ends to your input peripheral and you are good to go. The only one that is slightly more complicated is our alert beacon activation button. And this is only because of the LEDs on the front. The LEDs let you indicate the state to the user. So for instance, in this example, we'll have a green light when it's not activated and a red light when it is activated. If you're unconcerned about the LEDs, then all you need to do is use the blue and orange wires exactly as we showed in the previous example. Nothing else here needs to be done. But if we are worrying about the LEDs, we have to make a few changes. So our blue wire will go to V out instead of this ground. And then we can see here how these connect. So common, our common ground is now going to V out. Our normal open or NO is still going to 1, but we're also using this to indicate a red wire. A red wire corresponds with the red LED. So when we're in this state where we are activating, we also activate a red wire. Likewise, the normal closed state in C is being used to indicate air green LED through air green wire. The white LED is not being used in this example. The black wire is the other side of the circuit for the LEDs. So what we have here is actually 3 complete separate circuits. And without belaboring the point of this slide, this is available on the knowledge base on help.alertus.com for future reference or used when wiring. But if you follow this picture, it will give you the exact functionality that we have described. For all other activation devices, it really is as simple as 1 wire into 1 wire into the ground for 1, and you are done. This is only done so that the alert beacon can power the LEDs, and this is the exception, not the rule. For all other cases of a peripheral device, the power source is not the alert beacon. It's only that LEDs have such an inconsequential power drain that we're able to configure them in this manner. All right, enough of this highly technical slide. Let's get back to the fun stuff. So output peripherals work like a backwards version of input peripherals. We still wire the alert beacon to the peripheral with 2 wires to make a circuit, but the communication is reversed. For an output peripheral, the switch that controls the circuit is inside the alert beacon rather than the other device. The alert beacon closes the circuit when it's activated, and it sends the electrical signal to the output peripheral. We'll see an activation occur on the right. So we can see this all happens simultaneously. Alert beacon is activated, sends the signal, the other device is activated as well. But remember, peripherals are not powered by the alert beacon. The electrical signal from the circuit is only used for communication. Peripherals come with their own power adapters and will need to be plugged in to receive power. For input devices, this is not necessary because it's only a switch for the signal. But for output devices, it is essential that you plug them in and power them. The wires for the output peripheral plug into the terminals on the back of the alert beacon are used in the same way as we would for the input peripherals. However, these will go to the output section labeled aux out for auxiliary out. The alert beacon supports 2 separate output channels. These are designated channel 1 and channel 2. You can see that they have 2 sides, A and B, similar to the one in return paths of the auxiliary in. We'll be using channel 1 as our example. Just like before, it does not matter which order we put these wires in. We just connect one end to the alert beacon, the other end to your output peripheral, and you are good. The LED Marquee, however, is a special kind of output device that uses a different connection method than the other output devices, called an RS-232 port. This port is sometimes also referred to as a DB9 or a serial port, but RS-232 is the proper name. The other end of the cable connects to an RJ12 port on the LED Marquee. The LED Marquee comes with a special cable that has these connectors on both ends. All you have to do is quite literally plug it in. And of course, plug the LED into the wall to power it. All right, that concludes the physical installation of the LED Marquee. And with that, we'll be moving on to the software configuration session. Input devices are configured directly on the Alertus web console on only 2 pages. The Edit Alert Device page of the alert beacon is used to designate what peripherals are connected to the alert beacon, and the Custom Event Triggers page is used to define what should happen when the server receives the message that one of these alert beacon's input devices has been activated. The Edit Device page can be found by navigating to Configure System, Alert Device, and then next to the intended alert beacon, selecting the pencil icon to edit that alert device. Once on the page, select the Advanced tab to reveal the settings related to peripherals. You'll see that right here. There are 2 aux in fields labeled aux in 1 and aux in 2. We wired our input into the first channel in our example, so we're going to use the aux 1 in field. The easiest way to set up activations is with a panic button configuration. These panic button configuration numbers are arbitrary and are only used for grouping together buttons of the same intended response. We'll choose panic button configuration 1, and in the next slide, we'll determine what the panic button configuration 1 will actually do. Okay, custom event trigger page determines what alert should be triggered when an event occurs. In our case, we'll be looking at an event when an input peripheral is activated. The page is found by navigating to Configure System, Custom Event Triggers, and creating or editing a custom event trigger. It is broken into 3 sections. The first is the general settings. We're going to give it a name. And by default, the custom event trigger will be enabled and stop processing will be on. This fits our use case just fine, so we're going to leave it as is. Next up is the events section. This indicates what events we are looking for to trigger a response. In our case, the source will be a panic button activation. This is a general category for all sorts of input device activations. We'll also add a criteria. So here's our event source. Now we're in criteria. This particular event will only trigger if the panic button configuration number is equal to 1. So here we say panic button configuration equal to 1. That means that only inputs assigned panic button configuration 1 will cause this particular event to trigger. We could set up additional custom event triggers for separate panic button configurations if we want them to have a different response. If we want all of them to have the same response, we could change them to all have the same number. And finally, we set the action that we want to respond. In this case, the action will be to play an appropriate preset alert when this peripheral is activated. I've chosen a preset on my system by the name of Lockdown Bravo, but you should select whatever preset is appropriate for the system activation for your input peripheral. Testing the device is as simple as scheduling a time, activating the peripheral, and confirming the system was activated in the web console. The device activation report will even show you a full list of all devices that were activated and how long they took to activate. Output peripheral devices are also configured directly on the Alertus web console. They use the same Edit Alert Devices page to designate what peripherals are connected, but they use a different page to dictate when a peripheral should be activated. That setting is assigned directly on preset alerts. Just like before, the Edit Device page can be found by navigating to the Configure System, Alert Device, and then to the attended alert beacon. Select the pencil icon to edit that alert beacon and open up the Edit Alert Device page. Once on the page, we will again go to the Advanced Settings page to reveal the settings on peripherals. Here instead, the AUX1 channel, here instead, we'll be looking at our AUX out channel rather than our AUX in channel. I've configured it to be a visual device, but you can just as easily change it to an audio device with this setting. Additionally, the RS-232 device field is used to configure the LED Marquee behavior. You can see that is set up right here. You can choose between an amber or a red display and horizontal or vertical scrolling. I'm going to choose amber with scroll mode, which is the horizontal one. Whether or not you want a peripheral to be activated during a particular alert is designated on the individual preset alerts. The Edit Preset Alert page may be found by navigating to Configure System, then Preset Alerts, and creating a new or editing an existing preset alert. We'll be looking at the delivery method section of this preset alert, which is right down here. Specifically, we're going to expand on the settings of the Alert Beacon alert service by clicking its plus sign. You'll see that is located right here. Click on that plus sign will expand the alert service like so. So here we have our same specify delivery methods. We're just zoomed in to only show this portion. At the bottom of this expand section, we can find the peripheral settings. This is where you can toggle on and off any peripherals that you would like to activate or not activate for a given alert. The selection is by category. So for instance, you could turn on all visual devices, but leave off all audio devices if you desire. This was the purpose for setting things to audio or visible or other devices. There are multiple settings on that page, but for our examples, we're just showing audio and visual as our types so that you can configure whether or not you want a given type of device on a given type of preset alert. The same way that you could configure a given panic button to activate a given response. Testing of output devices is just as simple as input devices. You schedule a time, you send the alert, and you see if it goes off. In general, in my experience, they do go off. All right, and that concludes our fast and brief walkthrough of alert beacon peripherals, both input and output, including the RS-232 LED Marquee type of output. If you have any questions, comments, or concerns, I'm now opening up the floor for anyone who would like any additional information on any of your peripherals or their configuration. Please do not be shy. All right. Chat looks pretty barren. No one's speaking up, so I'm going to go ahead and call it for today. I hope you all have a lovely rest of your day.